This is Indira, Assistant Professor of Institute of Aeronautical Engineering, Department of Mathematics. Today we would like to know the definitions and terminology of matrices. We all know that before starting any concept, we should be alert of the notations and the definitions and terminology that are frequently used in that topic. So the very first definition is, what is a matrix? Define matrix. A rectangular arrangement of elements in rows and columns is called as a matrix. A rectangular arrangement of elements in rows and columns is called as a matrix. Define a row matrix. A matrix which have a single row is called as a row matrix. A matrix which has a single row, 1, 2, 1, 1, 2, 3, 1, 1, 2, 3 is a single row, and the order of this matrix is nothing but 1 into 3, and here this represents the rows and this represents that is 3 represents the columns. Define column matrix. A matrix with single column. A matrix with single column is called as a column matrix, and it is given as 3 into 1. Here we can see that 3 rows are there and single column. 3 rows are there and single column. So number of columns is 1 and number of rows is 3. Define null matrix. A matrix in which all elements are zeros. If all the elements are zeros, then it is called as a null matrix. Define a real matrix. A matrix is said to be real if all its elements are real numbers. All its elements are real numbers. Define complex matrix. A matrix is said to be complex if at least one of the element is an imaginary number. Okay, suppose you have 1, 2, 3, 2, 0, 1. Here one element is there which makes this matrix as a complex number. So must and should at least one element should be a complex number. If at least one element is complex, then it is called as a complex matrices. And sometimes all elements may be complex also. Next, what defines symmetric matrix? A transpose of a square matrix which is itself, that is A transpose is equal to A. Transpose is what I mean to say interchanging rows and columns. What is unitary matrix? A matrix A is said to be unitary if A to the power of theta into A is equal to A into A to the power of theta is equal to A, where A to the power of theta is nothing but the conjugate transpose of the matrix. When a matrix is said to be orthogonal matrix, a matrix is said to be an orthogonal matrix if A transpose into A is equal to A into A transpose is equal to 1. If this property satisfies, then that type of matrix is said to be orthogonal matrix. What is a transpose of the conjugate matrix? A matrix obtained by interchanging its rows and columns and also replacing the complex numbers by its conjugates is called as a transpose of the matrix. What is involutory matrix? A matrix A is said to be involutory if A square is equal to I. A matrix A is said to be involutory if A square is equal to I. When a matrix is said to be nilpotent, a matrix A is said to be nilpotent if A to the power of m is equal to I. A to the power of m is equal to I. And what are the Gauss operations in matrices? Row operations are called as a Gauss operations in the matrices. And what is the rank of the matrix? The rank of a matrix A, this is a very important concept in matrices. The rank of a matrix A is said to be R if R plus 1th order minor is equal to 0 and rth order minor is not equal to 0. Again, the rank of a matrix A is said to be R if R plus 1th order minor is equal to 0 and rth order minor is not equal to 0. What are the normal forms of the matrices? IR, IN, 0, 0, 0, IN, 0, and these are the 3 normal forms of the matrices, where IN is nothing but the identity of order n. Identity of order n. Identity of order n. Order n. What is the rank of identity matrix of order n? The rank of identity of matrix of order n is n itself, because you know that the determinant of identity matrix of order n will be equal to 1 itself. So which is not equal to 0, kabatti you can say that it is nothing but if it's not equal to 0, then it is nothing but the order n. So next, what is the rank of the diagonal matrix? It is the order of the given matrix. The diagonal matrix has a rank, its order. Now, what is the diagonal elements of the skew-symmetric matrix? All zeros. The diagonal elements of the skew-symmetric matrix will be all equal to zeros. So, the whatever it might be, and here the A minus A, B minus B, C minus C. So, best example of the skew-symmetric matrix. Next, what are the diagonal elements of the skew Hermitian matrices? Either 0 or purely imaginary. Either 0 or purely imaginary. 0 or purely imaginary. So these are the diagonal elements of skew-symmetric matrix. Now, what is when a matrix is said to be singular? When the determinant of the matrix is equal to 0, then the matrix is said to be singular. And knowing about this property is very important to find out the inverse of the given matrix. What is the inverse of the identity matrix? When the identity matrix is inverse, it will get the same identity matrix. Now, what is the principal diagonal of the matrix? The elements in the leading diagonal is called as the principal diagonal. The elements in the leading diagonal 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this is nothing but the diagonal. This is not 1, 2, 3 are called as a principal diagonal. Principal diagonal. Next, when a matrix is said to be rectangular matrix, if number of rows of a matrix is not equal to number of columns, then that type of matrix is called as a rectangular matrix. If number of rows is equal to number of columns, then the matrix is said to be square matrix. If the determinant of the third order matrix is equal to 0, then what is the rank? Then the rank can be less than or equal to 2. What is the rank of the null matrix? 0. The rank of the null matrix is 0. What is the rank of the matrix? 1, 1, 1, 1. The determinant of 1, 1, 1, 1 is equal to 0. Therefore, the rank is 0. Next, if x plus y 1, the 2 into 2 matrix, 1 x minus y is equal to 3, 1, 1, 1. Then what is the x and y values? Here directly substituting the values here, x plus y is equal to 3 and x minus y is equal to 1. Solving these two, 2x is equal to 4 or x is equal to 2. Substitute x here. So 2 plus y is equal to 3 and y is equal to 1. So x plus y, x is equal to 2 and y is equal to 1. When A is equal to, capital A is equal to Aij, small aij of n cross n, such that Aij is equal to Aji, then the matrix is called as symmetric matrix, because I and J represents the rows and column of the matrix. If row and column of the matrix are interchanged, then the elements are equal, then that is possible for only symmetric matrices. Next, if capital A is equal to Aij of m cross n, such that Aij is equal to minus Aji, Aij is equal to 0, then the matrix is called as a skew-symmetric matrix. Next, when capital A is equal to Aij of n cross n, such that A transpose is equal to A inverse, then what do you call the matrix as? Orthogonal matrix. Just it is can be written as if A is brought on the other side, A into A transpose is equal to identity. So this is possible for only orthogonal matrices. Orthogonal matrices. Orthogonal matrices. Similarly, when A to the power of theta is equal to A inverse, then this can be written as A to the power of theta and A, you bring it on the other side, A to the power of theta into A is equal to I. This is a property on complex matrices and you call it as a unitary matrix. Unitary matrix. Next, every real square matrix can be expressed as sum of the symmetric and skew-symmetric matrices uniquely. Every real square matrix can be expressed as sum of the symmetric and skew-symmetric matrices uniquely. Next, every complex matrix can be expressed as sum of Hermitian and skew Hermitian matrices uniquely. These two properties are same. One property is on real matrices and this property is on complex. This is a property on complex matrices. The product of the two matrices is identity. If the product of the two matrices is identity, then how they are related with each other? If the product of the two matrices is identity, then they are inverse with each other. If A into B is equal to I, this is possible if one is the inverse of each other. That is, A is equal to B inverse or B is equal to A inverse. B is equal to A inverse. So this is the main statement that the Gauss has used to find out the inverse of matrices with higher order, more than 3. Sometimes for 3 also we can use it. The determinant of the matrix is defined by what type of matrices? Square matrices. The determinant of a matrix is defined on only square matrices. What is a minor of the matrix? The minor of the element is the determinant of the matrix obtained by deleting the rows and column where it is present. Okay, that is, suppose if I have a matrix as 1, 2, 3, 4, 5 and 2, 4, 6, 2, then what is the minor of 1? 1 is nothing but we are going to delete this and these two. So determinant of this matrix, that is nothing but 2, 6, 2, 4, that is 8 minus 12, which is equal to minus 4, is called as a, so minor of 1 is minus 4. So therefore minor of 1, element 1, okay, 1 is minus 4. So that is how we can define the minor of the matrix. Okay, so what is the eigenvalues? And these are all the definitions that we have learned just now. And how to find out the characteristic equation of A. Characteristic equation of A is given by determinant of A minus lambda I is equal to 0. What is and these are the definitions we are going to learn it in the next session. So for today's session, we have just learned the types of matrices. What is the identity what is the identity matrix, and how to find out this. What is the symmetric? What are the properties of real and real matrices? What are the properties of complex matrices? So on, so forth. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.